Welcome to video 10.2, where we are going to be talking about how to create, read, update, and delete nodes and relationships in Neo4j graphs. To interact with Neo4j, we are going to be using Cypher to do all of our create, read, update, and delete operations. And in this video, we are going to be using the Neo4j Browser interface to interact with the database. Now, as we've discussed, the primary way to interact with Neo4j is using this query language called Cypher. There's also a REST API similar to how we interacted with CouchDB, which we'll talk about briefly in the next set of lectures, but for now we're just going to use the Neo4j Browser interface. Now, much like the select from where block, which is the core idea in structured query language, in Cypher, the core structure of our queries is based on match and return. So match is kind of like where, but there is also a where statement we can use in Cypher. But match is going to show us the pattern that we want to match, and then return is going to indicate what we want returned, kind of like when we project certain attributes using the select statement in SQL. And there isn't really a concept of from in Cypher because what we're going to be querying from is whatever graph we're currently connected to. So let's go ahead and get started by creating a node in our graph. And creating a node is going to adhere to this normal pattern of ASCII art in Cypher. To create the node, we're going to start with the word create. And then we have our set of parentheses, which is how Neo4j represents a node. And then everything that we define inside this node is optional. So optionally, we can provide an alias that we can use to refer to this node later. And we'll see some examples of how that's useful in future examples. And then a colon and the label we want to apply to this node. And then in curly braces, any attributes that are part of this node. So again, everything is optional and we can create just a completely empty node. However, that's not really a very useful thing to do. So all of the nodes that we create in this demo are at least going to have a label, and most will have attributes, and we'll use aliases as appropriate. One thing to point out is that when we create a node, Neo4j is automatically going to assign a unique identifier to that node called ID. So let's go ahead and switch over to the Neo4j browser, and we're going to create a new node that has a label of student, an attribute called name, and a value of Tom for that attribute. So this is our Neo4j browser. We access this just using a web browser where we have the URL of the server and then we connect over port 7474. And I'll be providing more information to you about how to connect to our shared Neo4j environment. But in this area here at the top, this shows that we are connected to a database called demo, and we can type whatever commands we want to execute right here. And when we execute the commands, the output is going to be shown in the area right here below. So we're going to create our first node by saying create. We're going to open parentheses, and we are creating a student. And this student has a name, which is Tom. So the name is a property of the node. It's enclosed in curly braces. Tom is the value of this property. Student is the label for the node, and we don't need an alias right now. So I'm going to just click on the play button right over here on the right side. If you have just a single line of Cypher, you can just hit enter. If you have multiple lines, you can hit control enter, or we can always just hit the play button here. And we get this response that says, added one label, created one node, set one property, confirmed after 1 millisecond. So we'll talk more about our read operations in just a moment, but just to see what we created here, I'm going to type match and then in parentheses A and then say return A. And this is pretty similar to saying select asterisk from whatever table in SQL. This is just going to return everything that's in our graph, which currently is just this one node with a property of name and a value of Tom for that name. And if we hover our mouse over the node, you can see that we have the other properties pop up kind of in the bottom of this window. So let's go ahead and create a couple more students and some courses and professors so that we can mimic this example that we kind of sketched out in the previous video, where we have two classes that have been completed by a couple of students and taught by these two professors. So going back over to the Neo4j browser, I'm going to say create student Christy, and I'm going to create student Sarah. I'm going to create a professor with a name of Grimes. I'm going to create a professor with a name of Zhang. And I'm going to create these two courses. And course, we showed the property as being called title. And we'll say BZAN 6354 and BZAN 6356. All right, so now that we have created all these nodes, let's again say match A, return A. And this letter A that I'm putting in here is just an alias that I've defined, and this could be anything. I could say match X, return X, just as long as I'm using the same alias throughout this query. And so when we run this, all right, we see that we have a few additional things here. And one thing I will point out is that Neo4j has color-coded these nodes based on the label that's been assigned to them. So all the nodes with the label of professor are blue, the nodes with the label of course are red, and the nodes with a label of student are orange. So this is the output when we just match for a very generic pattern that is going to match anything. But if we wanted to match just a specific node, we could do that just by specifying that pattern. So we could say match student where we have a name of Tom, and we need to provide an alias for student in order to refer to it later. So I'm going to call it student S, and we're going to return S. So this is returning the alias that we have defined earlier in this cipher query. And when we do this, we get back just the one node Tom as our result. As I mentioned previously, while we can specify the pattern we want to match as part of the match operator, we also can use a where statement. And when we get more complex queries, this can come in very helpful for having more in-depth evaluations. So we could say something like match, and we're going to give an alias of S, and we're going to look for the student label. And I just hit Shift Enter to carry on to a new line instead of executing the cipher query. I'm going to say where s.name, so it's getting the student's name, I'm using the alias right here, equals Tom. And I'm going to return S. Okay, so we should get the exact same output that we got from the previous query, and indeed we do. And we can have more complex where statements. So we could say where s.name equals Tom, or s.name equals Sarah, and we will get back both Tom and Sarah from this query. So at this point, we've looked at creating nodes and reading nodes back out of our graph. Now it's time to take a look at creating relationships. And this is one time that using our aliases is going to be very critical. So in order to create a relationship, we need to match two nodes, and then we have a create statement, and we specify a pattern that describes the relationship between those two nodes. So in this case, we're creating a relationship between S, which is the student named Tom, and C, which is the course that has the title of BZAN 6356. This relationship has a label of completed and has a property called grade and a value of A for that grade. Okay, so we match our two nodes and we create the relationship and specify whatever label and properties that should be associated with that relationship. So let's switch back over to our Neo4j browser and start creating some relationships. So here I have just the same exact code that was just in the PowerPoint presentation, matching student Tom and course title BZAN 6356. And then we're going to create a relationship that follows this pattern. When we execute this, we get a confirmation. We set one property and created one relationship. And if we were to say match A, return A, we see that we now have a relationship of completed between Tom and BZAN 6356. And if we hover over the relationship, we see the property pop up there on the bottom of this window that we have one property called grade, and it has a value of A. Excellent. So why don't we go ahead and create a few more relationships. In this case, I'm going to look for my professor node that has a value of Grimes for name, and my course node that has a value of BZAN 6356 for title, and create a relationship between those two nodes that has a label of teaches. Okay, and we don't have to have an alias for this relationship. We don't have to specify any properties for this relationship. But in the future, if we did want to specify a property, we can always go back and add that. So for now, we're not going to specify any properties. I'm just going to click the play button to execute this. It says we created one relationship. So I'm going to just look at my graph again. And we can see that now we have Grimes teaching BZAN 6356 and Tom having completed BZAN 6356. All right, so I'm going to execute a few more queries here. I'm just copying and pasting. We're going to say that Christy has completed BZAN 6356 and 6354 with a grade of A and B respectively. Sarah has completed 6354, and Grimes also teaches 6354, and Zhang teaches 6354. So we have multiple statements here. This is one little trick in the Neo4j browser interface, is if we want to execute multiple cipher queries at once, we can just put a semicolon at the end of the line, and the interface will parse those all individually. I'm going to click the play button here. And we get back some response that all of these completed successfully. And now if we again say match A, return A. All right, well, it's not in the prettiest format here, but let me move some things around a little bit. And I think at this point, this looks a lot like the graph that we drew in the previous video. So we're getting into pretty good shape here. Now we could also specify some other relationships, like for example, we might want to say that Sarah is a friend of Christy. Now notice in this case we are referring to two nodes that have the same label, student. And so this first student node we're calling S1, that's the alias we're creating, and the second student node is S2. And these aliases are just something we're making up for use right now in this cipher query. It's not anything that has any long-lasting effect. So we match these two nodes and then we create a relationship that follows this pattern. S1 is a friend of S2. So let's execute this. And look at our graph now. And we see that we have this relationship between Sarah and Christy, that Sarah is a friend of Christy. And notice that right here, it shows the names of all of our relationships and how many relationships of each type there are. So that's kind of nice information. But as I mentioned, this is a directional relationship. So this is saying Sarah is a friend of Christy, but not necessarily that Christy is a friend of Sarah. So if we want this to work in the other direction, we just need to reverse the arrows in our cipher query. And we're going to execute this again. And then say match. And again, it doesn't matter what we use for our alias here. I've been using A just because that's the first letter of the alphabet, but S or X or anything else would work just as well. Now we have a bidirectional relationship between Sarah and Christy, and depending on how we are traversing the graph, that's something that we might need to be aware of. Now, as I mentioned before, we can also update both our nodes and our relationships by matching the node or the relationship and then using the set operator to write some value to either an existing or new property. So if we wanted to record the number of hours each class is, we can just match the class and then set that property. So in this case, we're going to say match C course title is BZAN 6354 set C dot hours equals 3. And when we run this, set one property completed after 3 milliseconds. And we say do our match and return. And we don't see any real change to the visual appearance of the graph, but if we hover over BZAN 6354, we see that there now is a property called hours that has a value of 3. We're going to do this for BZAN 6356 as well. So let's look at a little bit more complex of a cipher pattern, and we're going to use that to update some of our relationships. So let's say that, that Dr. Zhang and I don't each teach both of these classes every semester, but I teach BZAN 6354 in the spring, and she teaches BZAN 6354 in the fall. So I'm going to create a pattern. So I'm going to say match, and we want professor name to be Grimes. And the next part of the pattern we want to match is that we have a teaches relationship and Professor Grimes is teaching a course. Just need to match my case there. A course that has the title of BZAN 6354. So in this case, I'm not matching just a single node, but I'm matching this pattern of a node that has a property called name and a value of Grimes for that property, and a relationship called teaches, and we're setting an alias of R for that relationship, and this is going to be important in just a moment. And then the other node is a node with a label of course, a property of title, and a value of BZAN 6354 for that property. Okay, so this is the pattern we're matching. And then I want to set r.term to be equal to, and I teach this in the spring. All right, so when we execute this, we see set1 property completed after 3 milliseconds. Return our graph, and no visual difference here, but if we hover over this relationship, we see now that Grimes teaches BZAN 6354 in the spring. Okay, when we hover over the other teaches relationships, we don't see any properties at all. Okay, so let's do the same thing for our other BZAN 6354 professor, except she teaches in the fall. And so now when we hover over that relationship, we see that she teaches in the fall. And we're going to do one more. I believe I'm going to be teaching 6356 actually in both terms going forward. So we want this pattern where the professor is Grimes, there's a teaches relationship, and the course is BZAN 6356. And recall that our attributes are in this JSON format, so we can actually pass in an array just like we would in JSON and say, I'm going to teach this in fall and spring, just enclosing that in square braces. And when I run that, we've updated property on one relationship. Let's look at our graph once more. And we see that Grimes teaches BZAN 6356 in fall and spring. Now, the final thing we're going to look at is how do we delete relationships and nodes. And delete works in a very similar way to update in that we want to match some pattern of nodes or relationships. But instead of using the set operation, we just say delete to delete whatever node or relationship we have matched. So let's say I were to stop teaching BZAN 6354. What we want to do is match this pattern of professor teaches BZAN 6354, and then we're going to delete whatever relationship matches that pattern. So I'm going to say match, and my label is professor. I have a property of name, and I want Professor Grimes. And I'm going to give an alias of R for this relationship, and the relationship's label is teaches. And then we need our course, which is going to have a property of title, which is BZAN 6354. So this is the pattern we are matching, and then we want to delete R. Okay, so we didn't need to specify an alias for this node of professor because we're not doing anything with it, right? Same thing, we don't need to specify an alias for course because we're not doing anything with it. We do need to specify an alias for the relationship because the relationship is what we want to delete. Okay, so let's do this. Deleted one relationship. Now when we look at our graph again, we see that Grimes is no longer teaching Business Analytics 6354. Okay, so now let's say, hypothetically, for whatever reason, I am no longer teaching at the University of Houston at all, and we just need to get rid of my node altogether. You would think we could do something like this. Match P colon professor, where name is Grimes. So that's a valid pattern to match. And then say delete P, which is just the alias we're providing here. But when we try to execute this, we get an error message that says we cannot delete node 3, which just happens to be the ID that was assigned to my node, because it still has relationships. To delete this node, you must first delete its relationships. Okay, so there's not a lot of integrity constraints in Neo4j, and we're going to talk in the next video about how we can enforce some integrity constraints, but this is one thing that Neo4j is not going to let you do, is delete a node that still has relationships. So in order to resolve this situation, we need to delete the relationship I have with teaching 6356. Okay, now at this point, if we look at our graph, we see we have a Grimes node here that is not connected to anything. We have a BZAN 6356 node here that doesn't have anyone teaching it, right? Which might not work so well in a relational database, depending on the integrity constraints, but that's not something that Neo4j is super worried about. But now at this point, I will be able to delete the Grimes node. So when we do this, completed in less than 1 millisecond, look at our graph one more time, and you can see Grimes is no longer in our graph. So this has just been a real quick look at the basic create, read, update, and delete operations in Neo4j. We can do some much more sophisticated pattern matching and get some really cool results, as we're going to see in some upcoming videos. So stay tuned.